Machine guarding, keeping it simple, is not making something overly complex in your design.
Things that kind of just explain just by the part what it does.
Well, like, see, we have this. We make this one part.
If you have an overly complicated design, that's more things that can go wrong.
It does make installation easier because then if something does happen to be off a little bit, the person would either have to send it back or try to file it themselves or drill something out, and that just adds another step to the entire process. It's just another thing that can go wrong.
The point guard, you can stand right next to the machine and operate it and be safe and be very close to the point of operation. The real advantage to the point guarding personally is that you can get close to the machine. You're not worried about a giant barrier that you then have to add complexity onto. So a simple physical barrier is the simplest way of making that location safe. If you can't get to the danger, you're all set. Don't worry about the emergency cutoffs or any other safety systems. A physical hard barrier to prevent somebody from hitting that danger point.
Keeping in mind all of the other ramifications for the guarding. Are you going to be blocking an emergency egress? Is your material appropriate to the temperature or other environmental factors such as chemical exposures? Accessibility. How often do you need to access the guarded component via inspections or lubrications? All these things are things you want to keep in mind when designing the guard.
Make sure you've thought about the process, really. A physical guard could indeed be the final solution there. However, if it's a complex location or there's other traffic patterns you need to worry about, maybe you need to be involved in other parts of the overall safety situation.
There are quite a few steps when safely guarding a piece of equipment in the workspace. However, following a few basic steps and keeping some data in mind can keep it a fairly simple process. Before you consider guarding, it's important to keep three things in mind. Firstly, have some safety procedures in place. It's important to know what to do in an emergency situation, both for those operating the equipment, but also for installing the guarding. You want to make sure that the guard itself doesn't impede the safety of the machine or the workplace. Secondly, make sure you have proper training. It's important that those operating the equipment know how it works, but it's also important for those designing and installing the guarding to know how the equipment works, so that way the final guard doesn't impede the function of the machine. You want to make sure the machine can still do its job, even when safely guarded. Finally, have some sort of documented safety standards on hand, be they from OSHA or ANSI B11, an insurance company, or something you just have in-house. You can't follow rules unless you have a set of rules in place. Machine Guard and Cover Company also suggests having some sort of safety evaluation done. Having a third party come on site to determine not only how severe an injury would be, but how frequently it may occur can be very helpful when designing guarding and figuring out a hierarchy of needs for guarding equipment. In this presentation, we're talking about hard guarding or point guarding. For the sake of simplicity, we're not going to be going into interrupts, light curtains, or anything outside of physical barriers preventing people from accessing worksite hazards. Keeping that in mind, we're left with four guarding options. The first being no guarding at all. Having no guarding installed at all is really only an option when the hazard is completely out of reach. An example might be an overhead conveyor system or a garage door opener. There's no way that during normal operations an employee could reach up into the hazard area and endanger themselves. The second guarding option is partial guarding. This is only suitable in applications where the functionality of the machine would be inhibited by the installation of a complete guard. An example might be a chop saw. Yes, at times the guard might be pulled back, exposing the hazard to those using the equipment, but the tool won't be able to do its job with the guard in place all the time. Third option is your standard hard point guarding, something that Machine Guard and Cover Company is very familiar with. An option like this is suitable for most applications, especially in situations where size, space, and simplicity are all important factors. Finally, you have enclosure guarding. In areas where the hazard is so dynamic, it's impossible to guard the entire thing directly. For example, a robotic arm. A robotic arm has such a dynamic range of movement that establishing a safe perimeter is really the only way to keep someone from being injured on site. Finally, Two important things to remember when designing guarding or installing guarding in any type of equipment. Firstly, guarding must not inhibit the function of the machine or add any inherent danger. If a guard is preventing a machine from functioning correctly or adding any danger to an environment, it's not really doing its job. Secondly, no level of guarding can protect against ignorance or malice. If someone is actively trying to injure themselves or the equipment in the workplace, there's not much you can do to design against that. Physical guarding is for when the machine is operating within its standard bounds of operation. Those are the basics of hard guarding or point guarding. Now let's take a look at some data. This chart is a representation of a Miosha study showing injuries in the workplace in which guarding was involved. The first section of this pie chart is the largest and arguably the most self-explanatory: handling or dropping oversized and heavy guards.
So the customer sent us this thing as a guard. It was mounted 20 feet in the air and it weighs 30 some odd pounds. I can't imagine. Can it falling off that'd wake you up, wouldn't it?
It would kill you.
It would kill you, straight up.
Kill you. If it hit you in the head, you would be dead.
31 pounds?
31 pounds.
So like 20 feet in the air or something. I can't imagine that either. It was on a Hummingbird press, and the vibration was knocking the mountings loose.
You could put Loctite in every one of these screws, but if you had to maintain this and do some maintenance to it, you would have to take them back out, which is a real pain in the butt. So that's not really a good solution to the problem.
Well, you just forget once, and it's gonna come down.
Yep, it's gonna come down, you're gonna wear the threads all,
Right.
you have to heat them up or whatever you have to do with the Loctite. So a good alternative would be probably make that guard out of up to 1/4 inch black plastic ABS. Would probably weigh 5 pounds. If it fell on your head at that point, it might hurt a little bit, but it's not gonna kill you.
No, this thing's enormous, and weighs a whole 15 pounds.
And that's a great example of, this is a really big guard. Another problem with the heavy one is it's going to take more than one person to install and reinstall that thing, take it down. You can't really juggle that thing.
I don't think I can hold it. And
Especially if
I'm
you're
a
on a
shoulder
man lift,
underneath it,
yeah.
and then try and get the wait, where's the screwdriver? Hang on, I don't, yeah.
And then you're
So-
going to drop it, and then you could be the cause of somebody's death.
Yeah.
You could take this down. You can hold it with one hand. You can flip it around. Do what you need to do. It would be a lot easier to balance on a ladder with if you had to, or a man lift. And you're not really risking people's lives at that point.
When dealing with any type of equipment in the workplace, there are typically 3 phases of a standard machine's life.
You first have maintenance. When you're working on a machine, this is when it is typically powered down, although once in a while you may need to test something with it powered up. Setup, when you are getting a job ready to go. Again, sometimes the machine can be powered down, but other times you may need to be actuating the machine through cycles to be getting the molds in position, or to be tuning in a production run. And then operation, general operation is the last cycle. Anecdotally, we see a higher rate of injuries in the operation phase from the users who've used the machine for years on end. They're the experienced ones, and they're not thinking necessarily about maintaining the safe operation because they've done it so long.
That example of individuals who have injured themselves during standard machine operation bring us to our next 3 points on the pie chart. The first of which is climbing on a guard. Unlike this pillow block bearing cover, machine guards don't always look like the hazard they're guarding. This means that it's pretty easy to misinterpret a machine guard as a potential step or seat. One of the first steps you can do to make sure people aren't climbing on guards is make sure they're labeled properly. Make sure that the hazard is indicated. One way of doing this is choosing the appropriate color for your guarding. Bright colors indicate hazards, but can also serve to the functionality of the guard.
One of the most common questions we receive at Machine Guarding Cover is what color a guard should be. Well, when the guard is in place, it really doesn't matter because at that point the danger is contained. What we recommend is a light colored backplate for ease of visibility to notice that the danger is exposed, the guard is not in place, and moving components such as this belt against a dark backplate cannot be seen as easily.
The next category is reached past or around the guard. In situations like this, it's important to consider if a worker should be able to reach around a guard at all. If the hazard is frequent enough you probably shouldn't be able to access the hazard behind the guard. It's also important to consider the way the guard is mounted. Basic temporary fasteners such as zip ties, Velcro, double stick tape, wing nuts, or even something fairly common like a slotted head screw or something like that can be easily removed from the workspace by practically anyone. Make sure that you have an appropriate fastener to hold the guard in place. That being said, if fairly frequent access to the hazard area is required for the operation of the machine, you may want to consider something like a light curtain.
Yeah, I mean, if you're dealing with just a particular hazard, light curtains really should be applying to areas where you have to be going in and out. There has to be access in and out of, and you need to activate the light curtain or deactivate the light curtain. And opening where you're feeding stock is a classic example of where you'd put a light curtain in, because then you're put your stock in, you get out of the area, the light curtain activates, actuates the machine, deactivate where it locks out the machine, then you go back in, remove the part, put the new material in. That's classic area where you'd be utilizing a light curtain, someplace where you need it, need the accessibility, but it's part of the sequencing operation of the machine. If you have a component that doesn't need to be accessed, a hard guard, point guard, is a much better application than, say, a light curtain or other area sensor.
Our next category is the guard being removed during operation. Guard removed during operation typically means that the guard was actually removed earlier when the machine was shut down due to service or maintenance, and then not put back on properly.
Machine Guard and Cover Company has come up with an option that avoids the whole problem of losing fasteners. And that's the safety captured fastener system, where, as you can see, the fasteners don't get lost. The ISO standards that have to do with guardings mention captured fasteners not as a requirement, but as a good idea. And there's a reason why it's a good idea.
If you get too involved in something and make it too complicated, people won't use it. They will discard it. They'll toss it to the side. They won't want to put it back on if it's too complicated for them to understand how to use it.
Now, many of us have been in a situation where we've seen a guard off on the floor. If we're lucky, the fasteners are in the guard, and nobody ever loses fasteners on a factory floor, right? Yeah, we know that fasteners get lost.
They have to go through an elaborate process on how to remove the guard and then put the guard back on. They're simply going to take it off, they're going to set it aside, and then they're going to find a different way of not using that guard, and then they're going to get hurt.
When the guard comes off easy, goes back on easy, and it saves you a great deal of time, it's a real saver.
I have seen firsthand people lose fingers. It's very important. It's a very big inconvenience to get hurt. And you don't realize that until it happens to you and you're not working for a month to 6 weeks because you have a bad injury and you don't have a digit. So it's I don't think a lot of people understand how important it is to have something guarded that can hurt you. And unfortunately, people don't realize that until they get hurt or until a shop has an injury that could have been prevented because the guard should have been on there and it wasn't. Now they have a huge expense in hospital bills, possibly getting sued or losing a great employee because he doesn't feel safe in the work environment anymore.
The next category is guards of inadequate size or position. Some of this is an easy fix, making sure that your guard is the right size to completely cover the hazard. For instance, if a shaft cover is too small, it leaves an exposed spinning shaft. This means that anybody with baggy or loose clothing, sweatshirt ties, jewelry, or long hair is at risk of being caught in the machine and potentially injured. Inadequate size position can also be referring to the allowable distance between a person and a hazard.
This is a gotcha stick, and the concept behind this is what is the safe distance away from the hazard based on the opening that is in the guard or in the machine. The concept is how far in is that hazard and is it far enough away? Based on this opening, we can see we have to be 3.5 inches away. The sheave is actually right behind this. We went with this mesh guard to save floor space, but then the shiv behind it was too close. This has no opening. So that shiv could theoretically be right behind this wall.
Our final category is inherently dangerous guards. It's very possible that you've done everything right, painted a guard the right color, made sure it completely covers the hazard, and made sure that everybody is aware of the hazard area. But if the guard is inherently dangerous, for example, it has exposed sharp edges, or perhaps it's in an inconvenient location, such as blocking a fire exit, the guard is not serving its purpose. It's making the workplace inherently more dangerous. The best way to resolve a guard that's inherently dangerous is just to think through the entire situation. Make sure the guard is safe. Make sure anybody with access isn't going to be hurt by the guard itself. Also make sure it's not inconveniencing anybody or inhibiting the functionality of any of the equipment. The best tool you have when designing and installing any type of hard guarding is your common sense. Keep that in mind, as well as your documented safety standards and the data we presented you, and hard guarding can be pretty simple. Thanks for watching this video. We hope you found it helpful and informative. If you have any other questions about machine guarding or are looking for machine guarding solutions, feel free to contact us through our website, www.machineguard.com, or through our Facebook page, facebook.com/machineguardandcover.